to discuss about the application of vector space. Introduction to vector space. A vector space is a mathematical structure that consists of a set of vectors along with operations of addition and scalar multiplication. Vector space are widely used in various fields such as physics, computer graphics, and machine learning. They provide a framework for studying and analyzing geometric and algebraic properties of a vector. Basis and dimension. The basis of vector space is a set of linear independent vectors that span the space. The dimension of vector space in the number of vectors in its basis. Understanding a basis and dimension is circular for slowing systems of linear equation and studying linear transform. Linear independence and span. A set of vector is linear independent if no vector z can be written a linear combination of the other. The span of set of vectors in the set of all possible linear combinations of those vectors. Linear independence and span are fundamental concepts in vector space that help determine the structure and properties of the space. Inner product spaces. An inner product spaces is a vector space occupied with an inner product, which is a function that assigns a scalar to the pair of the vector. Inner product space allow for the notion of length, angle, and orthogonality, which are essential in geometrical and physical application. Example of inner product space including spaces and function space with inner product operations. Applications in physics. In physics, vector space are used to represent physical quantities such as forces, velocities, and electric fields. The principles of vector space are applied in classical mechanics, electromagnetics, quantum mechanics, and relativity. Vector space helps in formulating and solving complex physical problems by representing them in a structured mathematical framework. Applications in computer graphics. In computer graphics, vector space are used to represent geometric object transformation and colors. Techniques such as scaling, rotation, and the translation of objects are achieved through operates in vector spaces. Vector spaces play a circular role in rendering relative images, simultaneing light effects and creating visual appealing graphics. Application in machine learning. In machine learning, vector space are used to represent data points further and model parameters. Algorithms such as support vector machines, neutrons, and clustering techniques operate in vector space or classification of regression tags. Vector space enable to manipulation and analysis of high-dimensional data, leading to the development of efficient mechanic learning models. Application in engineering. In engineering disciplines such as civil, mechanical, and electrical engineering, vector spaces are used to model physical system and analyze structural property. Concepts of forces, movement, and stress are represented using vector in engineering application. Vector spaces provided a material framework for solving engineering problems, op- optimizing designs, and prediction system behavior. Further directions and innovations. The application of vector space contains to involve the advancement in technical and interdisciplinary research. Emerging fields such as quantum computing, data science, and artificial intelligence rely on vector space concepts for developing innovating solutions. Further innovation in materials Science, robotics, and bioinformatics are expert to the involvement to power of vector space for addressing complex challenges. Conclusion of the vector space serve as a ver- versatility and powerful tool in various domains, facilitating the analysis, modeling, and optimization of system and phenomena. Understanding the principle of vector space enhances problem solving skills and enables creative application in diverse fields. By exploring the applications of vector space, we know we new possibilities for innovation, discovery, and advantages in science, technology, and engineering.